In this first section, we're going to cover factor by greatest common factor, or also known as GCF. Now, before, you have worked with terms or binomial terms where you FOIL and you distribute, which involves multiplication. So again, when you're FOILing or when you're distributing, the only operation that you are involved in that process is multiplying, aside from combining like terms. So again, when you're FOILing, when you're distributing, you're multiplying. Now factoring, it's the opposite of FOIL, it's the opposite of distributing. So which is, as you can see here, factoring, also known as factor, is the opposite or unfoil, and undistributing. So again, factoring means unfoil, to go backwards, opposite of foil. Undistributing, meaning opposite of distributing, to go backwards. So factoring is unfoil, undistributing. These two processes, or factoring, involves the only operation, which is dividing. So for distributing and factoring are opposite ends of each other. So again, foiling, distributing is multiplying, but factoring, which also means unfoil, undistributing, meaning dividing. As you can see, multiplying and dividing are opposite of each other. The same thing can be said for foiling and distributing is the opposite of factoring. So when I'm asking you to factor, or having you factor quadratic equations terms, I'm actually having you unfoil or undistributing where it involves dividing. So again, when you're factoring, basically you're just trying to unfoil, undistribute using the division operation. That's all it is. So now we're going to work on some examples on factor by greatest common factor. In our first example, we have 4x plus 20. So again, when we're factoring by greatest common factor, we're going to be dividing. We have two terms, 4x and the 20. So we're going to divide. Alright, so we look for the greatest common factor. That means what is in common, what is the greatest common in between these two, 4x and 20. So the only thing that is common between 4x and 20 is a number, and the highest is a 4. Now the reason I chose 4 is because 4 can go into 4 one time, 4 go into 20 5 times. So when I'm factoring, I'm going to divide these two by 4. So what I'm dividing by will be on the outside, which is right here. And then what I am dividing will be inside the parenthesis. So 4x divided by 4 will simply be 4 divided by 4 is just 1, so 1x, or simply just x. Positive 20 divided by 4 will be positive 5. So I factor out the greatest common factor, 4, and it's times multiplying to x plus 5. So I finished factoring, and this is our final answer. So again, you're just factoring to break it down into smaller, simpler parts. So you have two parts, and your simpler parts is 4 and x plus 5. Next, we're going to talk about this one. So we have two terms, negative 6m plus 18. So the only thing that's in common is a number. So what's in common between negative 6 and 18? I could use 3, but I could go higher. I could use 2, but again, I can still go higher. So what I'm going to do, besides 2 and 3, I'm going to use 6. Now what's different is that our first term is negative. So what I'm going to do is I'm going to divide the whole thing by negative 6. So unlike example 1, where it was positive, I divide by positive 4. And example 2, I'm going to divide by negative 6 is because our first term is negative. So if your first term is negative, you're going to divide both of them by -6. So what I'm dividing by is what I'm factoring. It's going to be on the outside, -6. And then what I'm going to divide will be inside the parenthesis. Alright, so -6m divided by -6. So basically, -6 divided by -6 is a positive 1. So 1m, or just simply m. Positive 18 divided by -6 will be -3. Alright, I finished factoring out by the greatest common factor. Nothing else I can do. So this is my final answer. -6 times m minus 3. So I broke it down from -6m plus 18 into two smaller parts, -6 and m minus 3. So that's pretty much it. In example 3, we have 25x to the third minus 15x. Alright, so our two parts is positive 25x to the third and negative 15x. So, unlike example 1 and 2, besides a number, there's a variable involved on both sides. So that means our common factor will be a number and a variable. So let's focus on just a number. So between 25 and 15, what's common between those two is 5. And the reason I'm dividing by positive is because our first term is positive. Now, we have x to the third and x. So when you have a variable like this, and they're both the same letter, usually we focus on the lowest exponent. So over here, x has an invisible 1. So we're going to divide both terms, by x, or x to the 1 power. So again, to review, when you're factoring out a greatest common factor that has variables on both sides or more, you usually focus on the lowest one, so x to the 1. So what I am dividing by is what I'm factoring, so it's going to be on the outside, so 5x, and what I'm dividing will be inside the parenthesis. So 25 divided by 5 will be 5. Now, when we're dividing with same letter and different exponents, so again, it's an invisible 1. So when we're dividing, we're going to subtract the exponents from top to bottom. So 3 minus 1 will be 2, so x squared. So here, negative 15 divided by 5 will be -3. And then if we look, x to the 1 power divided by x to the 1 power, it's the same thing, so we'll divide into 1. So 1 times 3 will be just 3. So 25x to the third divided by 5x to the 1 power will be 5x squared. Negative 15x to the 1 power divided by 15x to the 1 power will be just simply -3. So that will be our final answer. There's nothing I can do to simplify. So this 5x times 5x squared minus 3 is our answer. Those are the factors for 25x to the third minus 25x. Example 4. We have negative 24x squared minus 3x to the fifth. So our two terms are this. Now, besides number, we have variables on both sides and they have same letter. So we're going to factor out a common number and a common variable. So if we look between negative 24 and negative 3, the only thing that is in common is 3, because 3 can go into 24 8 times. 3 can go into 3 itself 1 time. Now, I'm going to divide by -3 on both terms because the first one is negative. Both of them have x, so I'm going to have x. Now, the one that I'm going to divide by is the lowest exponent, which is square. So I'm going to divide both terms by x squared. And then what I'm dividing by on both terms, or more, is the common factor, which will be on the outside. So negative 3x squared. And what I'm dividing will be inside the parenthesis. Alright. To take a look at each part individually, negative 24 divided by negative 3 will be a positive 8. X squared divided by x squared will be simply 1. So 8 times 1 is just 8. Then moving on to the next part, negative 3 divided by negative 3 will be a positive 1. X to the 5th divided by x squared. So since they're the same letter and they're dividing, I'm going to subtract the exponents from top to bottom. So again, from top to bottom, 5 minus 2 will be x to the 3rd. Now, you can keep it as 1x to the 3rd, or you can simply rewrite it as 3x squared times 8 plus x to the 3rd. Either answer is acceptable because it has an invisible 1. But if you write the 1, that's okay, because it's technically true, it's correct. There's an invisible 1. So either answer works. You can write it as negative 3x squared times 8 plus 1x to the 3rd, or just simply negative 3x squared times 8 plus x to the 3rd. Either answer works. So in these two examples, we factor out number and variable, and then when you have variable at the same letter, always pick with the lowest exponent. And when you're dividing with exponents, all you're doing is subtracting the top exponent by the bottom exponent. In our fifth example, we have 14m to the 6th power p to the 2nd power minus 6m to the 3rd power p to the 7th power minus 10m to the 9th power p to the 5th power. So unlike the first four examples, we have two terms. In here we actually have three. Here's our first, here's our second, and here's our third. Now let's look at the numbers first, the coefficients. 14, 6, and 10. They're all even numbers, so they can be divisible by 2, but is anything higher besides 2? I can't divide 14 and 10 by 3. I can't divide any of them by 4. And I cannot divide 14 and 6 by 5. Nor I could divide 14 and 10 by 6. So I think I'm pretty much good with 2. So I'm going to divide everything by 2. Now, they all have variables, which is m and p. So that means we're actually going to divide not just by m, but also by p, meaning two variables. So let's look at our m's first. So we have m to the 6th, m to the 3rd, and m to the 9th. So what we're going to divide by is the lowest one, which is m to the 3rd. So everything will be divided by m to the 3rd. Next will be our p's. So we have p to the 2nd, p to the 7th, p to the 5th. So we're going to divide by the lowest, which is the 2nd. So p squared. So again, we're going to divide each term by 2, m to the 3rd, the lowest for the m's, p squared, the lowest for the p's, on each of the terms. So since we're dividing by our common factor, it will be on the outside. So 2m to the 3rd, p squared, and what we're going to divide would be inside the parenthesis. Alright, so let's look at the first one. If we focus on the number, the coefficient, 14 divided by 2 will be 7. m6 divided by m to the third. So basically 6 minus 3. So what's left over is 3. And then p squared divided by p squared. The numerator and the denominator is the same, so it's just 1. So we're just going to have 7m to the third. Alright, next is negative 6 divided by 2. Negative 6 divided by 2 would be negative 3. M to the third times m to the third. Numerator is the same as the denominator, so it will become 1, so we don't have to worry about that. Next is p 7th divided by p squared. So it's basically going to be 7 minus 2, which is 5. So we're going to have p to the 5th minus. The reason I have minus is because negative 10 divided by 2 will be negative 5. Next, m to the 9th divided by m to the third. So basically 9, this is the exponent, 9 minus 3 will be 6. So it's going to be m to the 6th power. P to the 5th divided by p squared. So basically the 5th, the 5, minus the 2. So it's going to be 3. So p to the third. So that's what we have. To review, we divided or we factor out our common factor 2m to the third p squared on each term. The reason I chose m to the third was because it's the lowest exponent for each m. I choose square for the p's because that was the lowest exponent from all the p's. Now, when I'm dividing, 14 divided by 2 was 7. m6 divided by m to the third is m to the third, 6 minus 3. P squared divided by p squared just becomes 1. That's why I only have 7m to the third. Negative 6 divided by 2 would be negative 3. M to the third divided by m to the third just simply become 1. So we only have next is p 7th divided by p squared. 7 minus 2, which is 5. So the m to the third divided by m to the third become 1, which is why we only have minus 3 p to the 5th power. Next, negative 10 divided by 2 is negative 5. M to the 9th divided by m to the third. When it's dividing, basically 9 minus 3, 6 for the m. P to the 5th divided by p squared. When it's dividing, so basically exponents, 5 minus 2, which became p to the third. So this long answer is our final answer. So in this example we had 3 terms, but when you factor by greatest common factor, it's the same process as the first 4 example. Especially when we have multiple variables. In this one we had m and p, 2 variables. So again, if you have multiple numbers, multiple terms, multiple variables, the process still applies. It can be the same thing, just a bit longer. Just be very careful with our exponents. That's where mistakes can be easily made, so make sure to write it carefully, examine carefully, and then double check before you turn in your final answer.